Alright, today we're gonna solve intersection of two arrays, LeetCode number 349. Um, let's redo this problem. So given two arrays, write a function to compute their intersections. So with an input of num1 and num2, we want to return the intersection of these two arrays. So in this case, it will be 2. Since one doesn't, there is no one in array 2, so we don't return 1. So the second example is 495 and 94984. So we want to return 9 because in both arrays we have 9 and then 4 as well. 5, only nums1 array contains it, not the other one. So that's why we only return 9 and 4. So the brute force way of doing this is iterating the first array. While iterating the first array, we also iterate the second array. So that's a nested loop to check if the first array element, the current index of the first array element, if it does contain in the second array in current index, right? So that's a nested for loop that will, so the runtime complexity will be O of n square. And since we're not creating any space, we're not creating any new data structure, the space complexity is O of 1, right? So that's the brute force. And so let me just write that down. The time complexity will be O of n square, and the space complexity will be constant because we're not really creating anything new. So let's think about if we can improve our time complexity. So one way to improve our time complexity is when we can use sets. So we can have like a set approach. Because if we convert these two into sets, then one, it will remove the duplicated elements. So in this case, num1 will just have two elements of like 1 and 2, and num2 will have an array of just one element of 2, right? So the first step of the set approach is convert both convert input arrays into sets, into a set, uh, put into a set data structure, right? Once we have both of them, both of the array into sets, we can actually call, there's a special function in sets called like intersection, and we can just return that intersection, right? So so like what will our time complexity be? The time complexity of this will be O of n, and the space complexity will be O of n as well, because so n as in like the I'm sorry, n plus so let me see. Space will be a plus b. So A as in the first array, B as in the second array. That will be the second space complexity plus, actually, plus C as in the output array. Once we, oh, actually, no, we don't have to have a C. So the time complexity is O of n because we don't have any nested loop. We are iterating through each array one at a time. So that way, so technically our time complexity is n plus n, which is equals to 2. Uh, uh, sorry, n. So the time complexity will be a plus b as well, depending on which one is bigger. If a is bigger, then it will be a. So let's just call it C. C as in like the largest array between the two input array we have. All right, so now we got the logic down. Let's code it out. So let's say let's declare our set. Let's set one equals to set of type of integer and nums1 for each. So we're iterating through each element. So we want to do set1 dot insert our current element, and we will basically do the same thing for our set2. So let me copy that. 2. Now, once we finish that, we can return the intersection of the two sets, intersection of set1. We have to declare as a variable because we're mutating it. Let me build that. We have to cast it as array because our return type is an array. So I have this sample two arrays from here, and let's see if this will work. Run it. Perfect. All right.